So let's drop straight into this high-stakes thought experiment. Imagine you've got this massive remote control in your hands and you just hit pause on the continuous 24-hour rotation of our entire world. Now, obviously, we don't usually feel it as we just go about our day, but our planet is constantly in motion. And I mean, 5 seconds, that sounds like absolutely nothing, right? It sounds like, just a tiny, completely harmless hiccup in the server. But as we're about to see in our simulation here, tweaking this one planetary variable is going to unleash absolute, unprecedented chaos. But before we actually hit that pause button, we kind of need to look at the baseline data of our simulation. Right now, down at the equator, our giant 3D pixel Earth is spinning at roughly 1,670 kilometers per hour. Yeah, that is the massive, totally unseen velocity we're dealing with before the glitch even happens. And it's exactly that speed that lets the Earth complete one full rotation in 24 hours, giving us our whole day and night cycle. So we're all currently riding on this enormous spinning rock at supersonic speeds. Which leads us to the big question: what on earth happens when that number instantly, violently drops to zero? Well, how exactly does the physics engine handle that sudden drop to zero? It really all comes down to momentum and inertia. Think about, say, standing up on a really fast-moving bus. When the driver suddenly slams on the brakes, the bus stops, but your body, it wants to keep moving forward at the exact same speed you were just traveling, right? Now, just apply that to the entire Earth. When the planet's bedrock suddenly stops spinning, literally everything that isn't bolted deep, deep down into the Earth's crust is going to keep moving forward at 1,670 kilometers per hour. People, cars, whole buildings, everything is instantly thrown forward at an absolutely terrifying velocity. And man, the chaos doesn't just stop with solid objects. Our atmosphere? Yeah, it's moving too. The planet hits zero, but the air just keeps right on going. Literally milliseconds later, we're hit with winds that are vastly stronger than any hurricane in human history. Massive trees, uprooted. Entire cityscapes just shredded. Everyday debris instantly becomes this storm of terrifying, high-speed projectiles. The air itself suddenly turns into a destructive weapon, just completely tearing across our 3D pixel environment at supersonic speeds. Oh, and the water in our physics engine? Yeah, it doesn't exactly just politely sit still either. That massive momentum violently rips the global water supply forward. We are talking towering waves here, giant tsunamis instantly washing over entire continents. Every single coastal city around the world would be catastrophically flooded in a matter of seconds. Massive cargo ships, local fishing boats, marine life, all of it just violently thrown around by the sheer, unstoppable force of the moving oceans. It's wild. Okay, let's just take a deep breath, slow things down for a second, and basically pause the simulation to look at our leftover variables. Because, amidst all this crazy destruction, a lot of people mistakenly think that if the Earth stopped spinning, we'd all just sort of float away into space. But actually, no. Gravity is the force that attracts a body toward the center of the Earth. And that force comes entirely from the Earth's mass, not its rotation. So gravity is still fully active in our engine. You wouldn't float away at all. You'd be pinned firmly to the ground or, well, violently sliding across it while those supersonic winds and giant waves just roar right past you. And the sheer contrast of this whole event is what's truly mind-bending. In just those 5 seconds, if you were somehow actually able to look up at the skybox of our simulation, the sun would appear almost exactly the same. Because the Earth is only paused for 5 tiny seconds, there wouldn't really be a massive visible change to the cycle of day and night. The cosmic lighting, it stays exactly the same. But down on the surface, the damage is completely done. It's this crazy juxtaposition, this tiny 5-second window of time against just a massive, completely unrecognizable scale of destruction across the entire planetary surface. I know, this whole scenario sounds completely terrifying, but here is the good news. Outside of our little pixel simulation, this is literally impossible. Scientists confirm there is absolutely no known natural event that could ever suddenly stop the Earth rotation like this. Our planet is simply way too massive, and hitting those planetary brakes would require an unimaginably massive amount of energy.
So it's strictly a fun, chaotic science question, definitely not a real danger. Really, it just serves as a great reminder of how incredibly thankful we should all be that our giant rock is smoothly spinning every single day, keeping life totally safe and stable.
But it does leave us with one final, pretty provocative thought to end our simulation on today. If stopping the Earth's rotation takes that unimaginable amount of energy, well, what would happen to our 3D pixel world if all that energy somehow sped the planet up instead? I mean, the sheer power and the incredibly delicate balance of planetary physics is just absolutely mind-blowing. Anyway, thank you so much for joining me in this explainer today. And hey, remember to appreciate that smooth, continuous spin the next time you step outside to watch a sunrise.